So, hello everyone, today I will start the next lecture of module 7, the surface modification techniques. So, before that we will quickly review the last lectures. In the last lecture we discussed what is surface modification, why we need to do the surface modification, what are different objectives for the surface modification, starting to design the anti-fouling or self cleaning surfaces, to prepare surfaces which inhibit or restrict the biofilm formation or bacterial adhesion, to regulate the protein adsorption, to regulate the cell attachment or the cell adhesion. So, these were the few objective of the surface modification we discussed in the last lecture. So, today's lecture will discuss what are different surface modification techniques. So, we will discuss what are the physical techniques, what are different chemical techniques and biological techniques. So, first we will just see the overview of different modification technique, then we will briefly discuss a few selected techniques, particularly from the physical and chemical methods. So, as we discussed in the last lecture, the purpose of surface modification to alter the surface property. So, we are going to alter the surface property. Why you want to alter? To enhance the biological performance or to improve the intended functions while retaining the bulk property, means without interfering with the bulk property of a biomaterial. So, classically when you talk about the biomaterial, so if it is a unmodified one, so we may observe the non-specific adsorption, and non-specific adsorption of protein, it may lead to the protein denaturation which is undesired, and this protein denaturation may lead to the biofouling and ultimately failure of the implant. So, to improve this biomacromolecule and surface interaction, initially the polymers were coated on the surfaces. Later on the modified polymers were used to resist the non-specific adsorption, and down the line recently the self assembled monolayers are being used. So, we will discuss what are the different modification technique to prepare the modified surfaces to improve the biointerfacial interactions. So, what are the factors, or you can say what are the physiochemical factor of the surfaces which we are going to tune by the surface modifications. The first is the surface chemistry. Surface chemistry, it will depend on the what is the coating material or what is the coating agent we are going to use, that is going to regulate the surface chemistry, coating agent, its composition. Then next comes the wettability. Now, depending on the surface functional group, it may be hydrophilic or hydrophobic. Or in between, it can also be of the moderate wettability. Next comes the surface potential, means you can tune the surface charge. So, this will contribute particularly towards the electrostatic interaction. And this we can say the surface chemistry, and they will contribute towards the, let us say, hydrogen bonding, even they may contribute to the covalent hydrophobic interactions. Apart from this selective interaction, the van der Waal interactions will always be there. Now, next comes the surface roughness. So, the surface roughness can be tuned to increase the surface area. Also, as we know, this surface roughness and wettability is related by the Benzal equation that we have discussed earlier, Benzal equation. So, basically if you are increasing the surface roughness, means you are increasing the surface area of contact, and that surface area is going to regulate the interfacial interactions. Also, apart from this surface roughness, the surface texture may include that its pore size, what is the pore size, sometime it may say what is the porosity of the coating. Apart from the surface roughness and surface texture, another important thing is the thickness of the coating, and based on the thickness we may call the thin film or the thick film. In case of thin film, its thickness should be less than 1 micrometer, and if it is greater than 10 micrometer, we call typically the thick film. So, in this way, these are the properties which we can tune by applying different surface modification methods. So, how to modify the surfaces? So, I have quickly overviewed different methods. So, you can go for the roughening. So, in case of rough surface, you can go for plasma etching, you can go for mechanical roughening. We can form the pattern surfaces. So, pattern can be formed by the lithography, 3D printing, self assembly or direct writing. Also, we can go for this multi-layer films. So, for the multi-layer, we can have different biomacromolecule layer by layer assembly. So, we can go by the layer by layer assembly because they lead to the multi-layer adsorption. Also, we can go for the precipitation, particularly the precipitation of, let us say we are having, you want to form the apatite layer. So, we precipitated, then next layer, then next layer. So, we can go for the multi-layer films. Also, we go for the grafting, we want to graft a functional group here. So, it can be done by the plasma grafting, radio grafting and the photo grafting. You can say simple coating. So, the pulse laser deposition, solvent coating or the plasma spray, these are the simple coating. In fact, we can also go for the gradient coating. So, the gradient coating includes the ion implantation, ion beam assisted deposition. So, these are the summarized a few methods to design or to get the modified surfaces. Again, this modification route can be classified as a physical, chemical and biological. So, physical method applies plasma or the laser. Biological methods utilizes biomacromolecules like the proteins and nucleic acids, and chemical methods applies the polymers or self assembled monolayers. So, these are the few broad classification of surface modifying route. It can be physical route, it can be chemical route, it can be the biological route. Now, in the physical methods, we are having a solid, it has to coat on the surface. surface is also solid. Then first solid has to go to the vapor, then from the vapor it can be again coated on the surface. So, from converting from this solid to the vapor, we apply different instrumentation technique. So, the solid can be converted to the vapor by the evaporation or the plasma. Now, plasma can be generated by the arc, it can be generated by the arc, it can be generated by the gas molecule, particularly inert gas, or it can be generated by the laser. So, this plasma cloud converts the solid target to the vapor and then it is deposited on the surface. So, depending on the what is forming the plasma cloud, it is named the plasma arc spraying, it is also called the cathodic arc spraying, sputtering, pulse laser deposition, molecular beam, epitaxy. In this case, again the solid is coming, epitaxy means it is coming from the above and it is getting deposited. You are having a heated crystal surface and it is coming from the top and getting deposited. The molecular beams of that particular atom or the particular compound or gas it is coming. So, typically it is used for the deposition of the same crystal on the crystal substrate. Other method may be the electrodeposition, or we are going to have the computer programmed 3D printing. We can do the roughening, or you can say the etching of the surface. If you want to make the pattern surface, to make the pattern surfaces we can go for the lithography. Also one can go for the hydrothermal treatment. You keep the material in the presence of surface, give a temperature at a very high pressure, it is the hydrothermal. One simple may be UV treatment, if very much you want to expose with UV the outermost layer, or you can go for very simple spin coating, where the sol gel material or the material you want to coat we will put in the center, and this we are spinning at very higher speed, let us say 10,000 rpm. So, because of the centrifugal force material will distribute and form a film, or you can say thin film on your surface. So, these are the overview of the physical modifications. So, among them we will discuss a few of them in the next slides. In case of chemical methods, as I told, in case of physical we had the solid. Now, here we are going to have the liquid or directly the gas phase. This will be converted to the vapor and deposited on the surface, that is again the solid. So, the only difference between PVD is in the PVD the starting target is also the solid, but here the starting target is either liquid or the gas. So, again for this CVD we require the instruments. Apart from that we can go for very simple solution based method, or you can say this is like a dip coating. You are having the sealant solution, you dip your surface, it will be get modified by forming the self assembled monolayers. So, if you are having the silica or the glass surface, we can use the sealant molecule, and if it is a gold surface, we have to use the thiol agent. Another method is immobilization. You can immobilize or you can cross link using different chemical agents, particularly bifunctional or multifunctional cross linking agent like a glutaraldehyde. Also, we can go very simple, the acid and alkali treatment to modify the outermost layer, or we can go for the polymer grafting or the coating of the polymers. In case of biological modification, we have to coat the biological macromolecules, so which includes it may be the proteins, it may be peptides or peptoids, it may be nucleic acid, it may be the DNA or RNA, it may be the lipid molecules or it may be the carbohydrates. So, for applying the biological macromolecules, we can go for the physical adsorption, we can immobilize them using some immobilization methods like gel entrapment. You can have a agar layer on the surface, you can immobilize your biological macromolecules. You can go for the cross linking and conjugation. So, for cross linking again you have to use the bifunctional or multifunctional molecules like one example is the glutaraldehyde. So, it is like CH2 whole 3 COOH and again this HOOC. So, it is a bifunctional. So, one functional group can bind to the surface, one functional group can bind to the protein or biomacromolecule. So, here the advantage with the biomacromolecule, they have lots of functional group. Which facilitates or enables their attachment or modification on the surface, but again there is a challenge when we modify them or when we apply them on the surface, it is important to retain their activity. So, retain their activity because particularly for the, if you consider the protein, if their particular conformation is not present, they lose their activity or their functions are lost. So, this is a major challenge with biological modifications to retain their native conformations, or you can say to maintain their activity. Now, we will discuss the selected few modification techniques. In the physical, first we will display the plasma spraying. So, here you can see this is your substrate and this is the coating is taking place. So, here you are having the anodes and cathode, and this is your powder material which we are going to inject, and with the plasma it is coming and it is getting deposited on the surface. So, this is like a jet generation, then particles heating, then coating formation. These are the three major steps here. So, this is the plasma jet. So, because of this, as it is coming through the cathodic, so you call it a cathodic arc deposition. So, basically because of the arc, very high temperature is generated, so that this plasma is formed, and again the material which we are going to coat here, it is coming here in the plasma and getting coated on the your substrate. So, if it is performed at the atmospheric pressure, we call the arc plasma spraying, and if it is performed in the low pressure, we call the vacuum plasma spraying or the low pressure plasma spraying. So, here because of this arc we get very high temperature. So, we can use the high melting point materials like titanium, stainless steel, tungsten, zirconia and aluminum. So, these materials can be easily applied, and we use this non-reactive plasma gases like argon, nitrogen, helium or hydrogen. In case of sputtering, so rather than generating the plasma, they use the arc, cathodic arc particularly. Here we are going to use a RF power, or you can say the AC power, and this power varies between 1 to 5 kilovolt between the, this is your substrate and this is your target. So, what is happening? You have to generate a plasma cloud here. So, for the plasma cloud, this gas is coming, and once the gas, inert gas is coming, let us say argon is coming. So, here once we apply very high RF power, then these gas molecules get ionized, and this ionized inert gas form a plasma cloud. So, in the plasma cloud, a target is evaporated and it is getting deposited on your substrate. So, this is operated in the vacuum. So, the pressure lies in the range of 0.07 to 16 Pascal. So, here the challenges with the physical method is the thermal behavior or thermal stability. Because particularly these are the some high temperature methods. So, the stability, or you can say the particularly the thermal stability of this material or your substrate is important, and many times during the deposition it alters the crystal structure, or even it can alter its composition of the outermost layer, outer layer. So, these are the few challenges, that what should be the temperature, because the temperature you have to reach to vaporize your target, and target is the solid. So, typically it require a high temperature to form the plasma cloud, or you can say the evaporate the solid in order to get it deposited on your substrate. And when this sputtering is done in the presence of magnetic field, so it is called the magnetron sputtering, and this magnetron sputtering increases the plasma density due to the presence of a magnetic field. Now, next method is the electrophoretic depositions. As you know, we are having the two electrodes, and when the particles are suspended in the solution, they will be charged if you apply the electric field, and this charged particle is collected on the electrode and they form a coherent deposition. So, now the deposition will be similar to the shape of the electrode. So, here you can just see we are having a suspension. When we apply, these molecules will be charged, and after the charge, depending on their charge, they will move and get collected on one of the electrode and form a deposition. So, either cathode or the anode should be your substrate, and the target molecules will be in the suspension or in the solution. The another physical method you can go for the etching or simple roughening. So, we apply wet or dry method. Wet method means if we are using the solution, dry method if you are using some gas or vapor. Again it can be the physical etching if you are applying some inert gas as argon. It can be chemical etching if you are applying the reactive ions. If you are applying the inert, it is physical. If you are applying the reactive ions, it may call the chemical etching. Also it may be the isotropic or anisotropic. If the etching rate is same in any direction, then it is called the isotropic. If it is different or higher in one direction, then it is called anisotropic. So, for the etching or roughening we apply different methods. Very simple is the sandblasting, or you can use the abrasive paper like a emery paper. So, physically you can sandblast a surface, or we apply the emery paper to get the rough surfaces. Apart from this very simple physical method, we can also apply ion beams. We can apply the sputter or ion etching, or you can say we can apply the plasma for the etching, or you can apply the reactive ions for the etching. Here we are only having the different either ion beams or the gas plasma or the reactive ions, but there is no target. So, these ions will reach to the surface and they will etch or they will prepare the rough surfaces. So, these are the physical methods which we apply for the modifying a surfaces. Now, if you want to apply this method, so it will depend what is its physical and chemical property of the substrate and what is the target material, and accordingly we have to choose a method which we are going to apply. So, these were the physical methods. Now, we will quickly discuss few chemical methods. So, in the chemical methods, as we discussed, the first one is the chemical vapor deposition. So, in case of CVD, the starting material is the gas or the liquid. They will form the vapor and the vapor will reach to the substrate. So, this vapor will reach to the substrate. So, typically the gas reacts with the heated substrate and it results in a solid coating, and during this process the gaseous byproducts are removed continuously. So, here the coating thickness can vary between 5 to 10 micrometer. So, either you go for the PVD or we go for the CVD. With time this will be the coating thickness, it will keep on increasing like this. So, again this depends what is the target material, what is the rate of deposition. Even rather than reaching to the plateau, it can be also a straight line, means with increase in the time or deposition time the thickness is increasing. So, here the reaction is taking at the gas phase, because material is there in the gas or reactive molecules which is going to deposited on the, or you can say the chemical species in the gas phase, this is the solid phase. So, this is like a gas phase reaction, and gas phase reaction usually occurs at a high temperature. So, temperature varies in the range of 300 to 900 degrees centigrade. So, during the CVD, the first step is you have to transport the gas phase material to the surface region, then there will be the surface reaction, or you can say gas phase reaction, and along with this reaction whatever the byproduct is there because of the gas phase reaction, that need to be removed continuously from the surface, so that it should not interfere with the modified layer or surface modification. So, in case of CVD, again this is a high temperature because there is a involvement of gas phase reaction. So, if we can go for the liquid phase reaction, so one example for the liquid phase reaction is the self assembled monolayer. So, in case of the self assembled monolayers, they are formed the, as name suggests, self means they are formed spontaneously by interaction. This interaction may be the physical adsorption, it may be the chemisorption of your target agent or the molecular constituents from the solution or the gas phase on a substrate. So, here if you are talking the self assembled monolayers, so particularly this is there in the solution phase, and from the solution phase it is forming a covalent bond on the surface. So, here this surface modifying agent have the two groups, one group bind spontaneously on the surface and other group, a X group or R group, this decides the wettability or the hydrophobicity of the modified surfaces. So, here you are having a silica surface or clean surface, we hydrolyze it, so you form the OH layer. Now, this is your silane agent which is having 3 ethoxy group or 3 methoxy group. So, this ethoxy group will react with the OH group and there will be covalent bond between SiO and Si. So, basically it is a condensation reaction. So, it is covalently linked on the surface and X group will decide its hydrophobicity or the hydrophilicity. And if you are having the gold surface, you have to use the thiol coupling agent which is having the SS group, it will form the sulfide bond on the surface. So, in this way we form the self assembled monolayers. So, here the thickness is more or less controlled, because once the whole surface is covered, this is your surface, when it is covered by a layer, then the reactive group is no longer present on the surface, and if there is no reactive group, this chemical coupling may not take place unless and until this another group is going to react with this X or the R group which is away from the surface. So, this self assembled monolayer we will also discuss in module 8 in more detail. Apart from that, we can also have the polymer grafting. So, or you can say the polymer coating. So, this is done in two ways. We are having a whole polymer chain which is having a reactive group, and this group is going to interact or bind on the surface. So, this we call the grafting 2. Grafting 2 means this whole polymer chain is having a functional group which is attached, or you can say it may be the covalently attached. This is covalently attached here, and this X group is going to form a interaction or attachment with the surface. Another method is the grafting from. So, here we are having the surface initiator. So, there the monomer is attaching here, one monomer will come, then next monomer, then next monomer, then we are having the polymerization is taking place on the surface. So, this we call the grafting from. So, polymerization it initiates, then we grow the polymeric chain. So, this is a monomer unit, here we are having a surfaces with modified polymer. So, these are the two approaches, the grafting to and grafting from, to attach or to modify the surface with the polymers. So, here is the summary or you can say particularly what is the key challenges if you want to modify a biomaterials. So, as I told, for physical methods, one concern is the stability, and as we have to use the instrumentation, it is of course this initial cost is very expensive, and again this is the major drawback. We end up with the non-uniform surface modification, because it depends on the many factors, and also the target is evaporated coming in the gas plasma and it is getting deposited. Also, as this is a physical method, the strength, particularly stability in the biological fluid or adhesion strength between the coating and surface, it is still a concern using these physical methods. In case of biological method, again this biomacromolecule itself are very susceptible to the harsh conditions, pH, temperature, ionic strength, and again their immobilization and attachment, particularly the cost of biomacromolecule itself is expensive. Next comes the chemical method. It is more handy for this biomaterials, because it particularly the self assembled monolayers, it keeps the covalent linking. So, its coating is more stable. We are directly going for the liquid liquid reaction or liquid phase reaction. If you are going for the liquid phase reaction, it is cost effective and it is easy to perform. So, depending on what is your target, if it is titania or metallic surface, we can still go for the physical method, but if it is a polymeric surface which cannot be done by the physical methods, we have to go for the chemical methods. So, depending on the application, especially if you are targeting for the implant or the drug delivery or the biosensor, what is the material, then accordingly one should choose the different modification method. So, here I conclude this lecture. So, today we discuss what are the different surface modification methods. We can classify them as the physical, biological and the chemical methods. Then from each category we discuss what are the different techniques and what are the different methods, and then we discuss the selected ones like PVD, we discuss the sputtering, spray coating, we also discuss the CVD, then self assembled monolayers, we discuss the polymer grafting. Thank you.